Okay, so this was our assignment. First of all, I mean, you just need to calculate the reaction forces at point A, okay? As it is in part A, it's a, for most of the questions in strength of mechanics or mechanics of material, you need to make the free body diagram or FBD. For the okay, they draw the free body diagram for the rigid bar AB and determine the reaction forces AX and AY at a point A and the force acting in the rod CB, which is force BC. This is simple. I mean, you can calculate the AX and AY using the moment at B, and then calculating the Fx is equal to 0, Fy is equal to 0, and you can calculate the forces, which is which you did correctly. And I will just write down the answers. First of all, AX is equal to 40 kilonewton and AY will be equal to 60 kilonewton. And using, first of all, we have to make the free body diagram. So this is AY, this is AX, and so okay. So the answer for AX and AY is 40 kilonewton and 60 kilonewton. Similarly, you can calculate using the equilibrium equations. FBC is 50 kilonewton. Okay, so this portion, I mean, it's like the previous numericals, so it's not difficult. Stress will be same, which will be normal force over area. Once we will have this force, which is 50 kilonewton divided by its area. Area we have given 500 millimeter square, so we can calculate the stress. Stress comes out to be 100 megapascal. Okay, and in the next part it says determine the average shear stress in 20 millimeter dia pin at point A, that is which is subjected to double shear. So this means that this pin, that here is a pin. This is our rigid bar AB, and we have a kind of a pin connection, which is in this portion. So there is double shear acting on the pin. Acting on it. Okay, so for this now the pin is at A position. At A we have two forces, which is 40 kilonewton and 60 kilonewton. So to calculate the total amount of force, to calculate shear, we need total force, which will cause shear over its area. Okay? We need to calculate the resultant force, which will be R. So this is given, it is 40 and this one is 60, so we can calculate the total force. So this was the mistake in the assignment, so you have to be careful that which if there is only Fx or Fy, then you only use Fx or Fy, or else you have to calculate the reaction, the total reaction that is causing by these components. Okay? This will be 40 square plus 60 square divided by, now we have two areas, so either we divide the force by 2 or we can multiply the area by 2 pi. R is our 20 millimeters, so R will be 10 millimeter square, pi r square, and this comes out to be tau at A position will be 115 megapascal. Okay, so this was one of the what you can say mistake in the assignment, and after this the Third part is determine the relative distance between the 2 points C and B on the rod. Okay, so we have to calculate the delta which is caused by this force and how much it is extended. So this is in this we can use our delta BC, the formula that we have developed earlier in the course, which is PL over AE. So force in this condition, as we calculated, is 50 kilonewton multiplied with its length. Length is 5. If you can calculate using the hypotenuse, it will be 5. Okay, so which will be 5,000 millimeter divided by area. Okay, and into its E is 200 gigapascal, so we can convert into MPa, and this will be equal to, the answer is 2.5 millimeter. Okay, and in the last part it says determine the vertical displacement. We have to calculate the vertical displacement of the bar AB. So I mean, in this, due to the forces and due to all the forces that is acting on it, जब ये थोड़ा extend होगा, this bar will I mean, when if this is the rod actual, I mean the length before the loading, and when the load is applied, this rod get extended. Okay, so I mean, if this is extending, but this bar is rigid, as we have. Okay, so this bar will deflect downwards. I mean, this bar will rotate because this is pin connection in this kind of a manner. So अगर मैं इसको दोबारा draw करूं, so this is our actual, this is the delta BC, and now we have to calculate the vertical distance which is caused by this delta BC. So this is theta, we know this. We can calculate this by, this is 3, this is 4, and this is 5. So we can calculate the theta using tan inverse of the angle, which will be 3 over 4. And this comes out to be 36.87. Similarly, this theta will be equal to this theta because of corresponding angles. Okay, or you can even calculate the angles simply because this will be 90 degree and this is also 90 degree. You can calculate this angle, and I mean further you can calculate this, but it's simple corresponding angles, so you can theta will be equal to this theta. So this is 2.5 millimeter that we calculated. Now we have to calculate this distance. So I mean, using this sine theta and this formula, we can calculate this vertical distance. Let us call this is B. So this can be B dash. So delta B dot B dash will be equal to delta BC over sine theta. And then we can calculate this, which comes out to be 4.17 millimeter. So this was your assignment, which I gave in the last lecture. तो काइंडली आप लोग कोशिश कीजिएगा कि ये assignments note कर लिया करें, or along with the numericals that we do in our class. Okay. So today's lecture is about